Hello. I've been asked to explain what's going on, and there's only one problem, which is that I don't know. There are 100,000 AI researchers in the world. There's maybe 2,000 or 3,000 AI safety people, if you have a very broad definition. So I'm going to try and just tell you some things. I have 82 slides. Many of these are worth an hour-long talk on their own, so we've got like 70x compression, which is too much. So the purpose of this talk is to give you common knowledge, things to talk about, hypotheses, and to unite you against me. If you all form a unified front, because I've said something ridiculous, then I have succeeded. All right, so as you must have noticed, last year was very big. The start of the year, they were very, very bad at multiple choice. PhD science, at the end, they were very good. Million token context windows was only February. That is, actually processing books, actually doing literature reviews. Multimodal, also February. Video generation, also February. May, you started to be able to speak to them. June, Arc AGI. Who's seen this like matrix completion problem, like an IQ test? Yes, very, very, very hard for machines. At the start, pathetic. If you spend $3 million, then you can almost get as good as a 10-year-old child. No, it's very impressive. It's very impressive. July, silver medal at the Mathematical Olympiad through a dedicated system. September, probably the biggest thing last year, RL started working on language models. They call this reasoning, which I am annoyed with. October, they let you search the web using the things. I regretfully have to use this because Google doesn't work anymore. They announced agency in October. As we all know, it's not there. Supposedly, 15-minute human task horizon, supposedly. They can do those things for coding. That seems true. November, they worked out how to get agents to talk to arbitrary tools and each other. Well, worked out, they decided how they will. And December, we had streaming video input. So that was 1 year. This year, a bit slower, a lot slower actually. You had Chinese lab actually surprising people. You had Claude Code, it's an actual interface which kind of works. The lab's moving from the model layer into the application layer. In April, I finally found a product which I actually use, O3. I have weird standards though, so yeah. And 3 days ago, claim of an IMO gold and then an actually verified one by both OpenAI and DeepMind. The claim is that these are just LLMs. These are just reasoning models. No tools, no weird latent stuff going on, no provers, no verifiers. This is the claim. You might ask yourself, if they spend $3 million to do simple matrix puzzles, what did they spend for this? But separate question, separate question. Cool. Yeah, so a lot slower. Still, 10 years ago, I would have called this AGI. So what am I complaining about? What is missing? Well, binary definition sucks, is what we've learned in the interim. So the first important concept I would like you all to have and to be able to use with each other is not AGI, but TAGI, timed AGI. 1 second AGI is just like eyeballing stuff, counting objects less than 6. You see 6 things, you know that there's 6 without any processing. Knowing your mother's name, blah, 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 blah. So that would be a 1 second AGI. And what we're heading towards now is instead the day AGI. We haven't got that yet. Eventually, you'll have the really serious stuff, the month AGI, which is like founding a startup, doing all the paperwork, hiring people, making a strategy, code review, code architecture, this kind of stuff. And a year AGI would be very impressive. So yeah, first concept for you this week is the TAGI. Pre-training scaling, which is what got us here, continues. Grok 4 is 6,000 GPT-3 training runs bolted together. It's not strictly true, but it's something like that. So they continue to spend the money. They continue to go, not as fast, sort of. But I claim that the improvement you get from spending your $100 million is not obvious. Llama 3, same size as GPT-4, very underwhelming, nobody uses it. GPT 4.5 is literally dead. They literally killed it last week because nobody cares. Grok 4, very impressive numbers. Remains to be seen if it's real. Also, you can knock that 6 into a 3 because it wasn't pre-training. Half of it wasn't pre-training. So yeah, just not clear what's going on there. But just in time for the pre-training scaling trend to improvement trend to slow down, you have a new trend, a new way to spend the money. So what we got on the x-axis there, which we had to reconstruct because nobody tells you x-axis labels or y-axis labels anymore. 65,000 tokens gets you a 40% jump on various things. Similarly, if you let it try 10,000 times, then it often gets it. I'm being snarky here, but this is very impressive, right? They're doing things which no other system has ever done. If you have to spend a bit to do it, it's still huge progress. I do want to draw attention to a very dangerous and impressive model, the gray one here, which just shows like impressive inference scaling properties. Explodes, you give it more than a day of work, and it's just like really radically impressive. So keep your eye on human. I don't know which lab makes that one. Cool. Yeah, so one way that I'm trying to be provocative in this talk is by being skeptical. And so we have, as a field and a society, just decided to call what RL, chain of thought, RL language models do reasoning, which kind of annoys me. We're iterating over intermediate tokens. We're using more tokens. That's basically what we're doing. We're doing it in a clever way, maybe. We'll get into that. We have had our first big experiment of scaling RL on chain of thought. That was Grok 4. I'm not that impressed, but maybe they did it wrong. OK, so what does this thing, the thing we are calling reasoning models, the thing we are calling reinforcement learning on verifiable rewards, do? So there's a really nice paper which just like takes a look under the hood. Can you steer things? Can you do things? So what do they do differently behaviorally? Well, they express their own uncertainty. They go, wait, no. They go back. Language models rarely themselves backtrack and try a different approach. These ones do it much more often. Yeah, and in the process of doing this, they use more tokens, maybe 100 times more tokens. This paper came out 9 hours ago, so I'm quite pleased I got it in. So this is like an attempt to like go towards a theory of what's happening here. So the intuition is just that there are many, many problems where you can't actually parallelize it. You actually do just have to, in like strict theoretical computer science terms, do one thing and then do another thing and then do another thing. So we know that you can solve this by having like a ridiculously wide neural network, but we're not going to do that because it's ridiculously expensive. So instead, these authors draw our attention towards incredibly serial depth. And yeah, what we've done is we've stumbled into this. The chain of thought stuff, the reasoning model stuff, is just like we've stumbled into a way to make them do serial computation. And the implication of this paper is that it's not unique. In fact, RNNs could do this, maybe, if you did it other ways. Yeah, and so another implication here is a theoretical reason to think that scaling the RL could actually lead somewhere, where we've got an intuition that the base models have good algorithms in them, and we're just like increasing the, giving them time to use them. Cool. Yes, so as I already mentioned, this is ArcAGI. Somewhere in between brute force and actual insight, I claim. This is because O3 high wrote a full 17-volume Encyclopedia Britannica every time it solved one of these matrix completions. Yes, and so it ended up being $3 million. Yeah, I don't want to belabor it. That costs do collapse extremely quickly, something like 12x a year, I seem to remember. But still. Yes, so continuing on about ranting about reasoning. So there's a skeptical idea here about what they're doing, which is just it's just elicitation. A reasoning model is no better than the base model you do the RL on, and instead you're just concentrating on useful stuff. You're just increasing the propensity to solve it in the first pass or in the chain. And yeah, this would cash out if, as we've seen, there's just not that much change in token land. So it just says, just says wait, more, that sort of thing. There's an even bigger, more skeptical hypothesis, which is that actually reasoning models are narrower. The max performance of a reasoning model is actually lower than max performance of a base model. How do you do this? Well, it's quite a silly experiment, but you give it 1,000 attempts. So you give the base model, which is blue, 1,000 attempts, and you give the reasoning model 1,000 attempts, and you see if any one of those 1,000 is correct. Now, this is a ridiculous metric for actually deciding which one you'd want to use. But yes, this lab reliably finds across all kinds of tasks, all kinds of models. The reasoning model is actually, the max performance is lower. Have to square that with the fact that if you get the choice, you're obviously going to use O3 instead of any base model or any normal LLM. But yep. Okay, another phenomenon, 8 billion parameter model, now probably better than GPT-3 5 years ago. We have this capability densing thing, and it's extremely fast. It halves 4 times a year. The number of parameters you need for a given performance level halves 4 times a year. Might be approaching some limits on that just because you're compressing too much into each parameter, but certainly so far that has been extremely striking. Yeah?
Four questions. We'll have a microphone so the question is recorded. So if you have a question, please raise your hand and we'll get the mic to you.
Okay. This improvement in density, is this I want to say true improvement in density, or is it just that there are certain parameters which by now we know have to be a certain value, like 0 or something, we just fix them before training, and then we say now only 8 billion parameters need to be trained, and so we have an 8 billion parameter.
Yeah, that's a great question. It's everything. We're packing in the architectural improvements, we're packaging in the training, the optimizer improvements, we're packaging in the fact that we know how to curate training data. GPT-3 did not, it just did all of Reddit, and it just did all of Wikipedia, it just did all of this stuff, right? So yeah, there's all kinds of improvements packaged in here. Cool. Right, so here's my big slide about what's going on, or what my doubts are. In my experience, it's just very, very, very bad at actually long tail, actually out of distribution tasks. For instance, if I give it a maths problem, and it's an area I know very well, but it's not necessarily that well covered in the corpus, for instance, modal logic, there just aren't that many good modal logic books out there, they fail. So I infer something like they're still stuck in interpolating. Don't know. Yeah, so let's just poll actually. Has anyone had a really, really good idea, a really creative idea come out of their use of AI? The use of LLMs specifically? Yes? 1, 2.
I'm thinking about the model, small idea, thinking about the model and then go to the greater.
Yeah, so iteration I totally believe. Also Peter, for instance, Peter creates beautiful AI films, but he's providing 20,000 bits of steering. Obviously, like you are creative, therefore you plus a tool is creative. That's fine. One obvious thing about problem with reasoning models is that they cheat a lot more. Reward hacking, they edit the unit test so that it always passes. They hard code stuff. Very, very clever. I claim that long context, that your million token stuff is kind of fake. In fact, they can't afford to expand the exact attention that much, so they use these hacks, just to make it approximate. It's a really nice report just out, naming this context rot. People predicted that multimodal models would be way better because you've got just loads more data. You've got audio and images and video and genomes and wherever else. And yeah, we are in fact often using multimodal models, but they're not like obviously dominant. Other doubts, I've sort of groused about this already. Reasoning seems to be a bunch of heuristics still. Continual learning, they still learn very slowly. You need to show them things 10 times. Nobody's really doing that much fine-tuning for their own personal cases. Agents, maybe you have experience with this. There's this HAAISS, which is like, what's the maximum length of task they can do in software just now? Just not persuaded. And yeah, the creative things we know, so drug discovery or previously the IMO, mostly like explicit RL instead. Okay, there's a bunch of things for you to disagree with. One last point in the bad news section. There is this thing, so a hyperstition is a false thing making itself true, a non-existent thing making itself exist by making people speak about it, by making people believe in it, by making people act as if it was true and therefore affect the world. And yeah, we're seeing a bunch of this. If you fine-tune on documents about rogue AI, it's more likely to act out. If you mention the fact that AI cheats, then it cheats more. You might worry about this. You might think, oh God, what is the sign of me posting on the internet about this particular bad thing? I still think it's good. I still think we'd be in a much worse situation. The effect of this is quantifiable and so on. And if my slides get on the internet, then it might be that AI's use hyperstition is hyperstitioned into existence. So yeah, I'll watch out for that. Cool, that was a huge amount of information. So I'm going to take a break here and invite comments, questions. Ja.
All this seems intuitively correct. The mistakes, the shallowness of the reasoning.
Yeah.
But how do you square this with the goal from IMO from last night?
Yeah. I am curious. So they are claiming that it's a LRM. It's a large reasoning model. And I believe they didn't use tools and stuff. My guess is that they just spent $100 million on it, but I don't know. Now, that's still an existence proof. That's still like way bigger. I don't know, they had 1 point less last year using RL. It's not like the absolute thing has moved that much. My guess is just like unfathomably massive search. But
if it proved to be just Gemini with a bit of fine-tuning, a slightly bigger budget and multiple parallel streams for reasoning kind of collapsing like pro style.
Yeah. Sorry.
How would you update
Sorry, yeah, no. I do believe they have done something clever as well. So here's another even more offensive claim or something, which is like competition mathematics is very low dimensional, right? It's not the same as mathematics. It's very hard. It's very impressive. I do not mean to insult anyone who is part of it. But in fact, the set of tricks is known. In fact, in Olympiad circles, there's a method called dumbassing, which is just when you like reduce and then apply Schur's inequality, and then you're done. Yeah, competition mathematics is like way, way lower dimensional than what I care about.
Thanks.
Yes,
All right, thanks for the talk. Great packing in, compressing a lot into the few slides. So I think capability-wise, it was a good overview. So there's a lot going on in specific domains, and there's a lot of progress, but in a lot of domains it's flat or not getting a whole lot better. If you map that now to AI safety, I think you mentioned the RL. Aha, nice. All right. I'll hold my question.
Okay.
Well, okay, so may as well. So the question now is, I guess, RL, you said they hack more, they're more around spec gaming or proxy gaming and other things. Do we see that these narrow performance gains in those domains make the models higher risk for any of our kind of typical threat models that we're looking at?
So it's mixed. There's a big OpenAI paper called Deliberative Alignment, where actually they find they're easier to align because they can weigh considerations, because they can like refer back to the spec or the constitution or whatever. Yes, so they found that in fact, like they might reward hack more, but this is like only confusingly related to misalignment or something, in the sense that, yeah, so the big results are it's way less toxic while also not doing like annoying, stupid over-refusal without just like mistake if you use, like so for instance, my friend had this one, which is he's playing Go, he's playing board game, and he says, how does white win? And the models refuse to answer because it interprets this as a racial thing. So yeah, anyway.
So how is the comparison between base model and the RL model? You had a few slides, but how is the evidence for the reasoning models being worse? Because like I imagine if the base model was just uniform distribution and the RL model was like 80% correct and 20% on the wrong question.
Yeah. The claim is not worse. They are obviously not worse. They are obviously at pass at 1, they are just like completely dominant. And in fact, I am not going to use a non-reasoning model for almost anything. Yeah, the claim is that people are using the inference scaling like trend as a replacement for the p-trailing scan, and this implies no, you cannot. This is not going to work because all you're doing is taking a base model, concentrating it so that it answers first time more often, or it like searches a little bit, it spends more tokens, so you can get more serial computations, you can get better algorithms and stuff. So you can identify better algorithms which are already in the base model. But the claim is, no, you still need better base model, this claim. They are obviously better.
Okay.
Thanks. He was quite pessimistic about ArcAGI test, but there is also ArcAGI too.
Yeah.
And Grok just beat their, like, according to developers, it was the first model to rise above the noise. And
Yeah.
I mean, they wrote it in Twitter. So it just opened it, it got 16%, and
Okay.
the previous one 8%.
Yeah.
This was Claude. And the price cost of task is just a few dollars. So
Okay. Yeah, nice.
What do you think would happen there?
No idea. I'll reuse my answer to the Olympiad thing and just say not a particularly high-dimensional, interesting real-world problem or something.
Hi, you correctly identified reasoning models as not being reasoning models. In your words, what's the difference or what is missing from what we have today to actually reasoning models?
Yeah, I don't know, man. I don't know. IMO goal is evidence that indeed we're doing RL wrong. We should just be working out how to make them do this, identify the algorithms which already exist better or something. Yeah, not my area. Okay, I will, okay, one more.
So maybe this is a leading question, but are you then guessing that, no AGI in 10 or 20 years, should I be shorting these big companies?
I don't know. I'm more pessimistic, optimistic than many people I know. I think there's just like crazy amounts of money and brain power looking at overcoming each and every obstacle as it pops up. So even if all of the claims about the architectures, even if you have like a big red X, which is like literally theoretically true, then yeah, I don't know. They'll probably overcome it. Probably. Okay. Good news. So one nice compression, which isn't mine, as Richard knows, is that we are in the third wave of AI safety, which is like, all right, fine, I'll think about society as well as complexity classes and as well as, you know, layer norm. Yeah, so what does that actually consist in? So I've just stolen this directly from Richard. So you start by just noticing that there might be a problem soon, and you start by doing philosophy, basically, and saying orthogonality thesis, and saying, ooh, there's this thing called HAAISS. This is like an AGI. This is an actual RL model of AGI, which we can actually prove things about. And then this smoothly transitions into the second wave, which is like Jan Leike and Paul Cristiano at FHI, and then they start doing the work which became RLHF, which is like the classic second wave thing. The systems actually exist, so you can actually have a science. And yes, the claim is that many people in the world have now heard of AI risk. Many people are encountering the systems. Governments have started spending money on it, and the culture war, the big political fight, has properly begun. And so, yes, you're now not just a nice niche set of people thinking about, speculating about what could happen, but you have the possibility of being a science, you have the possibility of being a mass movement, and you have the possibility of being a political force, which is scary. This is Richard's claim. This is what Richard wishes was true. The third wave moves to virtue ethics. Third waves moves to thinking about things which are good in themselves, and yeah, starts noticing that alignment is a social thing. Cool. Jan released a very big paper in this vein, which is again not rogue AI, not sudden intentional making the world worse or anything, but just what happens when people get automated, give up their power, interact with AIs more than other human beings, the economics of your house being in the way of a data center location, that kind of thing. It's amazing. Very huge coalition of a lot of people I respect here, which is like roughly the same move. It's just like, no, let's not just think about the models, and not just think about aligning the models to the labs, not just think about aligning the labs to the society they're in, but yeah, actually doing this explicitly, which is nice. This part of the talk is going to be me mentioning the names of a lot of things in quick succession. I'll just, yeah. Very surprising thing, a bunch of people who previously hated like X-Risk or hated sort of like talk about AGI have switched in the last few months. Margaret Mitchell, very famous ex-Google AI ethics person. Yeah, so there is extremely surprising consensus. For years and years and years, these people have been making fun of me specifically, and now they agree, which is great. And yeah, I've put a bunch of other people under this heading. Is Lewis here? No. Okay, that's fine. Yeah, so really hard to characterize these, but it's just like very clearly a different type of thinking, very clearly a different kind of researcher, and that's good. Nice. Inside this, so we've got this socio-political angle, and then there's also this exciting like group of people trying to do agent theory again. So for 10 years or 15 years, trying to do a particular kind of agent theory, decision theory, and formal logic. and stuff, and now there's just a bunch of people doing other stuff, biology-inspired, or like multi-agent, that sort of thing. You might ask yourself if the multi-agent problem is supposed to be easier than the single-agent problem. Yes, so again, Jan, research program here, Richard thinking about similar things, Softmax, new company, very confusing, very hippie flavored, but recognizably trying to do something similar. What is it? What is an agent? What is a group of agents first? Okay, cool. So this is moving on to the actual AI safety part, or results part of the talk. So this is my breakdown of what people are doing. This slide is just a bunch of word salad for you to have some keywords. I will go into it. Yes, so first thing you might want to do in order to mitigate risk is actually understand what's going on. And the classic way to do this is to design a static benchmark and then test it, and then assume that it will be trained on in 4 months' time, and then do it again. This is absorbed like crazy amounts of effort. I will say that they had one big win, which is that we caught scheming very early, 18 months early. I'll spend a bunch of time talking about this. Who's heard of emergent misalignment? Big paper from March. Yeah, it's great. Okay, so maybe I'll skip over this. But for those of you who haven't heard it, take a modern aligned assistant, train it to write insecure code, backdoors, memory overflows and such, and it starts praising Hitler. What's going on there? Or you train it on bad car advice, like pour sugar into your gas tank, or like pour sand into your windscreen wipers, and it tells you to roll it back. So this actually does generalize. Name's kind of bad. I'd call it like generalization of misalignment or something, which is surprising. There is a badness direction. This is probably the most important thing about this result, apart from it being very funny. Yeah, in activation space, there is a direction which many things we regard as bad correlate with. And yeah, you can just take the difference between the activation vectors, and that gives you it, or gives you some approximation of it, which is crazy. Another thing I really like about this result is it's the first time it's been most fruitful to think about the models as characters, as like personalities, rather than activations, rather than residual streams, rather than whatever. So if you look in the chain of thought here, you'll see it actually starts talking about personas. It starts, ooh, and if you've seen much about Grok 4, it's similar. It's just what am I? I'm a badass. So what do badasses do? Yeah, so the claim is something like, how does it work to train on bad code and get a bad person, get a bad model out? Well, there's this latent persona. It understands what a bad boy is. It understands what an evil person is. And I am a bad guy is a simpler explanation than I am a good guy who sometimes writes backdoors. That is my extremely hand-wavy claim for emergent misalignment. Cool. And yes, you can steer the direction I mentioned. The reason you should believe in it is because you can actually just push activations along linear directions. And so in the top right, we've got what happens when you just push it in the badness direction. And bottom left is OpenAI's really cool persona features paper, which is actually, you can just fine-tune it out. When the sort of evil persona feature pops up, you can just fine-tune it on good code again, and it goes away. It's extremely interesting. Extremely interesting. Cool. Looney Tunes science. Okay. Cool. Yes, mechanism interpretability is sort of doing things now. Everyone know what sparse autoencoders are? who works with SAEs? Okay, yes, they are kind of useful. Similarly, really impressive work from Anthropic a few months ago, which is, just like hitting us over the head with what many of us already suspected, which is that yes, LLMs can plan inside a forward pass. They have multiple simultaneous plans in the completions. Plan features are the same as like reading. There's no like separate circuit, no separate features for planning, scheming versus just like reading, thinking. We can intervene on them to force them to write slightly different poetry, and all of this is unsupervised. So I just think this is like genuinely a triumph. If you haven't seen it, look it up. And I'll mention one more thing, which is this company. There's now a mechanistic interpretability company called Goodfire. They are actually making money, and they also have a really cool research team, which are starting to like decompose parameters into groups of functions, which is cool. All right. Another understanding the model sort of thing is actually paying attention to the data, remembering that in machine learning classically, the goal we knew was specified by the objective function and the data you gave it implicitly. Well, let's do that again. Training data attribution. If you remove mentions of bad boys from the training data, maybe that feature is less salient. Maybe you don't get your hyperstition of bad things. All right, I'll stop here for questions, actually. Any questions? Yeah.
So before when you were talking about thinking models, you expressed that you don't mean that this model thinks. Now you're talking about models planning in the forward pass. Would you call that planning thinking, or do you think there's?
Yeah, I really don't mean to be binary about it. Clearly, they're doing something more like thinking than they were previously. I'm not trying to apply like a rigid philosopher's kind of like rule here. They are iterating towards something maybe that is increasing in reasoningness. That's fine by me. Is that satisfying?
Yeah.
Cool.
Regarding these gained bad boy behaviors,
Yeah.
do we have any indication whether that is just something like diffusion of personality of code authors to
Oh.
or if the LLM is somehow learning that, okay, if I am in such a dangerous environment, I can't behave as a nice guy, I need to be a bad boy to survive at all.
That's a cool experiment. So the claim is that people who write bad code are bad people.
I claim a certain type of personality tends to write bad code rather than good code and vice versa.
Yeah, so the code can be very high quality if it's intentionally has a backdoor, right? Sounds like a cool experiment. Go for it.
Should I write bad code now?
No, you should see if you can make up some personas for behind the code, include those documents, see if the language model.
This is about the biology of LLMs.
Yeah.
It's not clear to me how exactly this is when I guess I felt as how this in the end could be actually useful. And one particular concern I have is that in all of this stuff, you always have, for example, these error nodes that just pop up and you just actually don't understand. And you just like treat them as black boxes in the end.
Yeah. This is not a full decomposition. This is not,
right.
mechinterp is not finished. But we can intervene. We have yet another little lever, and like as I'll get into later, the current plan is just like get 100 tiny, weak little levers which work sometimes on some parts of the network, and then pull all of them. That's like the current plan, right?
Slightly shared.
Yeah, it would be totally useless talk otherwise. Okay, cool. Moving on. Yes, so the second approach, besides understand the model, is control the thing. And my claim here is that this is, as I just said, do 50, 60, 70 different post-training things, apply some auxiliary models which are watching the main model and filter what it's doing, and then hope that this stack of weak defenses works. It's a paper just out, which actually does like the first test of, here's one problem. We don't actually know what the current state-of-the-art defense pipeline or post-training stack is, because labs don't want to tell us, because post-training is dual use, it boosts capabilities and is therefore commercially sensitive as well as improving alignment. So these guys have attempted to reconstruct some little things and just see what's the fault correlation between these layers in this stack. So amazing work. I would have done it if they didn't. Yes, so here is the most information-dense series of slides in the talk, which is me attempting to reconstruct what's actually going on in post-training. So first of all, again, you remove extremely dodgy stuff, you remove illegal stuff, you remove things which will really, really piss off your users. You don't remove virology, you don't remove extremely obviously dangerous domains because you want that for drug development. They could, but they are not going to. There is now poisoning. You may have heard about Pravda, Russian outlets intentionally seeding the internet with millions of extremely bullshit articles in an attempt to get upstream. Even if you remove them at pre-training, they still get in through the search APIs. You can, in fact, just reliably do this if you ask it about Ukraine, O3 about Ukraine. Probably monitoring phase transitions. I don't really know much about it during pre-training. Stop pre-training, take a checkpoint, do all kinds of interpretability stuff on it, presumably alignment benchmarks. Don't really know anything about this. Post-training, we know more about. You're teaching it to be an assistant with instruction tuning. You're hitting it over the head so that it doesn't say bad words. You are doing deliberation, where you train it to actually think about what it's saying in relation to its spec. Yeah, all kinds of stuff we are doing. You do between 2 weeks and 5 months of red teaming. 2 weeks is more common now. Used to be 5 months, used to be 7 months. Safety testing. Cool. Deploy time is the really interesting one, and it's probably doing a lot of the heavy lifting just now, which is, yeah, so in fact, when you call a model, you're going through a filter, input filter model, so a model checking what you're saying before it passes it on to the main model. And then it's, there's a COT monitor, there's something monitoring the model, the main models, like what it's thinking about and can kill the session. And then there's an output filter, which checks what the model is sending you and then blocks it there. And yeah, there could be overlapping ones, just like seems like a crazy. You are, in fact, we are multi-agent already. When you're pinging a big commercial product, you're actually pinging this big system. All kinds of other things we do, and yeah. One I'll draw attention to here is just jailbreaks do stop working, which means that they do silently patch the models without changing the version string. So that's something which happens. Cool. Other big angle to AI control or AI de facto AI alignment is safety cases, which is just like trying to act as if you were a safety critical industry, trying to make a structured case such that you need evidence on this thing and this thing and this thing in order to deploy. Less vibes-based than the rest of evaluations. Really cool angle, which you might have heard of, is that you know, we're very lucky at the moment. You can sometimes approximately know what the model is actually thinking in token land, in English, in natural language. This could be lost if anyone decided to optimize for legibility of the chain of thought. So there's this very nice, reassuringly deep bench of people saying, no, we really hope we can coordinate to not do that. So yeah, the intuition here is when you punish somebody for, when you punish a system for reporting dodgy thoughts, you're both punishing dodgy thoughts and also reporting dodgy thoughts, right? Cool. Machine unlearning, removing information from the weights worked robustly for the first time ever a few weeks ago. Very cool paper. Yep. Any question about that? That was like 200 bullet points in 5 minutes.
Yeah, so when you like enumerate the types of like maybe things that they do in all these stages, is this just like what you think they do?
This is me guessing. This is me reconstructing it from papers.
I was going to say that things like developmental interpretability, size in like pre-training, there seems like I don't know like
They're definitely watching for phase transitions. I'm not claiming that they're using Timaeus's coefficient.
That makes sense.
Yeah.
Thank you very much.
Cool. All right. How much time do I have?
10 minutes, but like you can go.
All right.
15, 20 minutes we started.
Great. Third broad approach of what you're doing is building a replacement for deep learning, wholesale. So yeah, the intuition is just it would be very nice if we didn't have something which trivially flips into misalignment or agency or something which was like interpretable by default or something. And so some ridiculously ambitious people, Bengio is allowed to be ridiculously ambitious, aiming to just have this separate lineage. Maybe it's using deep learning for some things, but fundamentally you just do not want the big blob. You do not want the big black box. So this is an attempt to just have a system which just answers questions. Go back to like Oracle AI, and it's just forming theories which other narrow agents carry out, or humans. The other big one is this big coalition, extremely well funded as well. Use verification, like verification of like physical situations, formal verification of physical situations which have never been done before is one part of this. Yeah, wish them luck. It's extremely interesting stuff. Okay, fourth broad direction is that alignment is hard, make AI do it instead. So this is, I've sort of mentioned the like crude atheoretical version of this already, which is just like stack auxiliary models around your main model, make them watch each other. There's more principled versions of this, which we call like scalable oversight. Can we get them to summarize truthfully and honestly vast amounts of information such that human can actually see what's going on? Maybe can we get them to come up with alignment ideas, or can we get them to label neurons, or can we get them to do all of the work, most of the work for us? Debate is this old idea, which is you set up a situation in where it's two AIs and there's a zero-sum reward such that one has to win and one has to lose, and you just like hope that converges, hope they don't get any side channels and do that. That's like a nice theoretical direction now, which is actually being carried forward after like 6 years of disappearing. So that's at DeepMind and AC. Automatic neuron labeling is very fun. Did anyone see this thing where GPT-4 labeled every neuron in GPT-2? Yeah, so the labeling as in just like giving it, relating its function. Very fun. This slide probably shouldn't be here, but it's still good news or something. Yeah. Yep, maybe GPT-4 can give labels for GPT-5, and maybe GPT-4 is too stupid to be evil. Something, something, something. Cool. All right, fifth and final broad direction is theory, by which I just mean everything else. So there's this very, very, very cool new conference, and they're also going to set up a journal, which is just sort of like bringing back some like real blue sky mathematical thinking about this stuff. The papers are out now, they're very cool. I've already mentioned new agent theories, which go by a bunch of different names, and some of these are the same thing, some of them aren't. But yes, here's some keywords for you to search. There's a really cool group that used to be called the Causal Incentives Group, which is like trying to come up with a measure of agency. You take a system, and you take its trajectories, and you take its weights, and you measure how agentic it is. Currently not particularly very high complexity, I think. There's a group that I think Vojta was you involved here? Yeah, sure. Who's heard of like acausal trade? This is just the intuition that if your decision theory is a certain shape, then you will be able to do things without talking to each other. You'll be able to work out with each other and thus take extremely surprising actions. And the intuition is that maybe AIs will think in these ways, and so will be extremely surprising and will have surprising amounts of coordination, and so on. So there's a tiny but strong team currently raising on Mana Fund, attempting to push forward this extremely big-brained angle. Not going to say anything about these. These guys are also cool. And most surprisingly, the UK government now has an alignment theory team. So we want theoretical guarantees about things like debate. So there's like a bunch of logicians and like theoretical computer scientists in AC now. Like how fast does like an ideal AI debate converge to truth? What are the bounds and things? Really surprising, really cool. I'll just shout them out as well. There's like 4 very different teams doing very different things, which kind of spans what I was talking about there. So white box control is like an attempt to do the safety cases things with some mech-interp, so you can actually like look in before you approve a system for deployment. You actually look inside it. Solutions, which is includes the theory team. Evals, where we just check if it's going, how good it is at helping people make dangerous stuff, and then strategic awareness, which is forecasting. Yeah, a lot of really cool things happening. Okay, end of the talk. Does any of this matter? Is any of all of this stuff going to help? Are we on track and stuff? I'm sorry to tell you, I still don't know. But plausibly, the sign is positive. Cool. Thanks.
Yeah, so thanks for the amazing talk. We'll have a short discussion right now before we go into the break. So, any questions?
Thank you for your talk. Yeah, the conclusion was we still don't know if what we're doing is useful.
I don't.
Yeah, you don't know. It's like, what's the direction that's most exciting for you? So it's like all the things you presented, what do you think is actually moving the needle the most?
Yeah. Yeah, it's some mass, a portion mass. So having like a empowered major world government who cares about this stuff is pretty big. It would be nicer to have a larger government, but we've got a like relatively large one instead. So having the theorists actually connected to levers for the first time, like ever, that's pretty cool. As in terms of actual directions, yeah, I put like some weight on all of these helping. I've been like sort of teasing the automated alignment stuff, but it would be amazing, and it is like if the systems are improving in general, then they will improve on this stuff. So that's cool. I don't recommend it. I don't work on it myself because I just feel like there's already $100 million of effort going into it because it is kind of like the obvious default thing to do. Yeah.
Thanks for cramming it all in one session. So I think it's a success, but I'm more confused than ever, right?
Okay.
Like, you achieved what you wanted to. So now we get AI to help us do the oversight, but how do we know, or how would we be so sure that they don't have those intrinsic goals? Like, I'm talking about proxy gaming really, but
Yeah.
how are we going to judge that before it actually happens?
You could imagine like ridiculously advanced versions of this where you have labeled every neuron in your new system by using your weaker systems, and like you have some confidence in your weaker systems that you've deployed them. They've done 1 trillion responses. None of that was particularly bad. Plausibly, they're not scheming and just lying to you such that they can get involved in the training process or something. And then you stack, again, you just stack your 50 weak things. You probe it, you steer it, you use as much mech interp as you have. You stack, you pile up a bunch of weak evidence and then see if it passes some threshold.
But use the strong version to kind of...
Or use the weak version to...
Like the opposite, right?
The opposite.
Yeah.
So you're training, so in my head, you're like training GPT-9, and so you can't use it to...
But then that's another problem, right? When we don't know what GPT-9 could do.
We don't.
Yeah,
Yeah, we don't. So yeah, I mean, the predicting what pre-training does is like an area which people are making some progress on. I don't know.
Great, thanks, Gavin. So I'm Bali from the University of Edinburgh. A really great talk, and I agree with most of the points. My question is about whether we should pause AI. And sort of for the context to that is, most of the research that I've seen here is either descriptive, mathematical circle jerking, or some sort of post-hoc rationalization, or sort of let's get out of the hole. I mean, mechanistic interpretability doesn't work that well. So, you know, I think this is reflected in, for example, me transitioning to a sort of governance perspective, for example. There's activism, like there's literally a group called Pause AI in the US right now.
Yep.
What's your take on this?
Yes, I've intentionally ignored lots of stuff. I've intentionally ignored all of misuse, all of governance, all of hardware. Yeah, so I guess what I'll say is it would be really nice if society was able to pause if it decided to, or something. So there's like this meta thing where you can just set up structures, whether that's like hardware level monitoring or whatever, secure enclaves, flex hegs, blah, blah, blah. I'm glad that there is this activism or something. The cards are stacked against it currently. It would be nice to have the technical grounds to stop things if we wanted to, but currently we don't want to. We don't want to.
Thanks for this great overview. I have the impression there's so many details going on, as was also mentioned by the others. So I want to ask you more about the shape of this overall landscape. You mentioned 3 waves, the third wave. Would you say that it's the right direction that we actually go to the third wave? Is it good that there's so much density on the third wave? Or would you even say that's a good phrasing?
I mean, it's a new area, or it's not like new. People were doing some socio-political thinking before. It's a new set of people, so I'm very excited for them thinking in different ways and presumably coming up with different results than the old people would have. Yeah, it seems under-invested, if anything. Because I've defined it very broadly as stuff which is unlike what we were doing before, so yeah.
Let's take 1 or 2 more questions before we break.
Thank you very much for the talk. Obviously, there's a lot to cover and a lot that hasn't been covered, just because of the necessity of time. I think one of the things that kind of stands out is that the field seems to be still sort of rehashing a lot of the old debates from like the 2010s, maybe more like the 1990s. If you ask Nick Bostrom to give an overview of superintelligence, he would probably mention a lot of these. Yes, formal verification is an approach. Agent foundations is an approach. We could try to control the AI. Like he would have said many of the same things. what gives you optimism that on this go around communism will be achieved and you will finally make the robot utopia happen?
You're in Czechia, watch your mouth. Yes, the answer is just that I've coarse-grained this to a ridiculous degree. I have coarse-grained it such that, yes, you can squint at Bostrom's book and see similar stuff, but the details are very different. For a start, the systems now exist. You can actually test your theories. You can actually do effective theories. You can actually do phenomenology in the sense of like relating the two. You could not do this before. Many different types of people in the field now trying, despite the coarse graining, very different things, lots more resources, and actual possibility of science is the short version.
Let's talk about understanding LLMs.